Alright, ladies and gentlemen, this is Mr. Anderson from Kellogg Community College, and we're going to look at a very popular page, the page 3 of the practice test. It's popular because it has the story problems on it, and I will let you know that because I'm doing a problem like number 9 does not necessarily mean that a problem like this will be on the test. In fact, any homework problem you have is fair game for the test, so please be aware of that. Alright, so the Spaz River flows at a rate of 5 kilometers an hour. In order for the boat to travel 30 kilometers upriver and then return in a total of 8 hours, how fast must the boat move in still water? Okay, so the distance equals rate times time. And we're going upriver and downriver. We're traveling 30 kilometers in both directions, and we can see that because in order for a boat to travel 30 kilometers upriver and downriver, or then return, so these are the same. Now, the water flows at a rate of 5 kilometers an hour. So if we go up the river, that's going to work against us. So our speed x, or r, in case you want to use r, our speed x is 5 fewer because of that forward current, and then going with the current, x plus 5. Now, the time is pretty critical here because it says it returned in a total of 8 hours. Now, we don't know the time, so we have to indicate 2 separate letter t's because it could be 4 and 4, or 3 and 5, or 6 and 2. But I pretty much can guess that it's not going to be 4 and 4 because we're going to have to travel at different speeds to get up and back in the 8-hour time period. So our time 1 plus time 2 equals 8. Now my story problems have a pattern to them, which means that at first you'll fill out the table, then you'll write your equation. So following the rules here, I'm going to write our equation. And then we're going to solve for t, and that usually gets us into a good position. So solving for t in both situations. And now what we will do is plug these back into the equation. So I'll plug in this for t1 and plug in this for t2. And now I have my new expression, which is 30 over x minus 5 plus 30 over x plus 5 equals 8. Now, what we learned back in Chapter 6 is how to rationalize the denominator. We're going to actually clear the denominator. So we're going to multiply everything by x plus 5, x minus 5. And if we do that, make everything x plus 5, x minus 5 times bigger, that's going to provide a lot of simplification. So x minus 5's go away. So I got 30. I'm going to kind of block this off here so it doesn't get too cluttery, even though I'm going to write a lot around here. 30x plus 5 plus 30 times x minus 5 is equal to 8 times this, which is simplified to x squared minus 25. So you could FOIL that out and see that it would be x squared plus 5x minus 5x minus 25, but it just is easier to write it this way. Okay, I'm going to distribute all of these. So I'm going to have 30x plus 150 plus 30x minus 150 is equal to 8x squared minus 200. Now a couple nice simplifications. On the same side of the on the left-hand side of the equal sign, the negative 50s are opposite of each other. So they simplify to 0. The 30 and the 30 add to make 60x. And I'm going to move that to the other side of the equal sign, so I get 0 equals 8x squared minus 60x minus 200. And now I got a problem that's ready for the quadratic formula. Now, when I use the quadratic formula, my a is 8, my b is negative 60, and my c is negative 200. Now, when we use the quadratic formula, since we're doing a story problem, and my letter a was positive, I am going to only use the positive of the plus minus of the quadratic formula. If you use the symbol that matches the a value, you should get the non-negative answer. So this gives me negative 60 squared minus 4 times 8 times negative 200. All over 2 times 8. And if you do all of this work up here, what you get is 10,000. So 60 plus the square root of 10,000 divided by 16, which is 60 plus square root of 10,000 is 100 divided by 16, or 160 divided by 16, or 10. Your answer for x is 10. So going up the river, you would be going 5 kilometers an hour, and going down the river, you'd be going 15 kilometers an hour. But the question just asked, how fast must the boat travel in still water? And that right there would be 10 kilometers per hour. Let's look at problem 10. There's my warning. Study all types of the DRT problems in this section. Anything on your homework's fair game. But one problem you probably haven't practiced enough is a work problem. Now the work problem is set up whereas the two people work together to finish one job. So these are two people working together to finish one job. So Catherine and Spencer can weed the garden. Catherine and Spencer can both weed the garden in 35 minutes. This indicates the total amount of time, but what we don't know is we don't know how much of them working alone would do the job. Now we do know that Spencer takes 24 minutes longer than Catherine to weed the garden. I'm going to put Catherine in front since she was introduced first. And Spencer takes 24 minutes longer, so this is x plus 24. So Catherine would just be x. So just like in the previous problem, we now have the setup, but what we're going to do is we're going to now clear the denominator. So everything gets multiplied by x and x plus 24. X and x plus 24. You're hearing the water pump in the background if you're wondering what that noise is. X and x plus 24. Okay, so these x's simplify. So I have 35 times x plus 24. This x plus 24 simplifies, which leaves me with just 35x. And then this is 1 times this, which is x squared plus 24x. Let me work a little bit more over here. So this is 35x plus 840 plus 35x is equal to x squared plus 24x. I'm soon going to be able to solve using the quadratic formula, but I need to move these two 35s over. So I'm going to subtract 70x from the 24, because 35 and 35 make 70. Subtract from that. And then I'm going to move this 840 to the other side, so that's going to be a minus 840. So here I have x squared minus, just making sure I got my numbers right, minus 46x minus 840. Now, I could factor this, but instead I'm going to use quadratic formula because the numbers are so big. A is equal to 1, B is equal to negative 46. Excuse me. Sorry, that looks bad. And C is equal to negative 840. So we're going to have B plus, not plus minus, because again, since my A value was positive, I'm not going to use the plus minus. If the A value was negative, then I would definitely use the minus. But I don't have to use both, because one will give me an answer that works, one will give me an answer that doesn't work. So I've got 46 plus, in parentheses, negative 46 quantity squared, minus 4 times 1 times negative 840. Whoa, that's pretty crazy. All over 2 times A. So I got 46 plus. All of this inside here is 5,476. If I did that on my calculator, divided by 2. And the 46 is then added to, if I take the square root of 5,476, it's 74, all over 2. And I would split this up if I, needed to, but I don't, because 46 and 74 make a total of 120. 120 divided by 2 is 60. So this means my x is 60, so Catherine takes 60 minutes to do the project by herself, and it looks like Spencer would take 84 minutes to do the project by himself, or an hour 24 minutes, but together they get it done in 35 minutes. So the answer to the question, because it says how long would it take Catherine to do this job by herself, would be 60. All right, so the last problem on this page, a little bit of memorizing. Determine the type and number that the solutions of this quadratic equation would be. Now, there's a small, to remember all this stuff here, you first of all just have to check the discriminant. The discriminant is the b squared minus 4ac. It's whatever's inside the square root. So if I got my a equals, my b equals, c equals, this should tell me what my answer is. Now there's a table we put into your notes that you should try to memorize. Because what happens if I get an answer where the discriminant is equal to 0, let's just call the discriminant d in this case. If I get the discriminant equal to 0, so the discriminant, or the square root of 0, is going to give me 0. I think that's probably some bad notation. Let me just make it simpler here. If the discriminant is 0, then what I have is I have one rational answer. Now, if the discriminant happens to be a perfect root, then what I have is I have two rational answers. Now, if the discriminant doesn't happen to be a perfect root, so it's non-perfect, then what I'm going to have is two irrational answers. And if my discriminant is negative, so this would be less than 0, then what I have is two imaginary answers. So let's give you an example here. Obviously, discriminant being 0, an example would be square root of 0. Perfect root, that would be, like the square root of 4, the square root of 36, square root of 100. Non-perfect, anything that isn't one of these perfectly rootable numbers, like square root of 5, 101, square root of 2. Two imaginary answers, well, anything that's negative, be it a negative perfectly rootable number or a negative not so perfectly rootable number. So again, going back to my problem here, I'm going to have x squared plus 5x plus 8 equals 0. So what I'm going to do is check out my ABC, which is 1, 5, and 8. So this gives me a 5 squared minus 4 times 1 times 8. And that gives me an answer of, if I type this into the calculator, a negative 7. And since this turned out to be a negative, I choose U. Two imaginary answers. There you go, folks. There's the dreaded page 3, and I thank you for watching.